Alright, ladies and gents, here's a little intro to trigonometry video. This is going to be the basics for the next chapter we're going to be covering. So the first thing we need to look at is something you've seen before, or at least I hope you've seen, is we're pretty much going to define an angle. So in the angle, we have two sides. We have an initial side and we have a terminal side. Now this terminal side can go in the positive direction, and it also can go into the negative direction. So for our initial sides here, and our terminal side goes this way, we're going to have a negative angle. That angle, we're going to refer to this whole chapter as theta. A little theta symbol. And that can be measured in degrees or in radians. Alright, and also, one more thing before I move on, something that we've seen before. One complete rotation is going to be 360 degrees. So if we have our initial side here, and our rotation goes all the way around to our new terminal side, this is going to be 360 degrees. Now to give a formal definition for a radian. Now the difference between radians and degrees is basically a radian is the relationship between a radius and the arc length. So let's say theta in radians is going to equal the S divided by the R. Okay, this S meaning this is our arc length, and our radius is our R. So for a full rotation is going to be pretty much the circumference of the circle, which is 2 pi r, divided by the radius, which in this case is just, that simplifies to 2 pi. So a full rotation is 2 pi. Alright, so theta in radians is basically the amount of rotations we do. So basically we can rewrite the coordinate plane using radians. So I'll start off, when we start, we're going to be on the x-axis here, so here's our starting, and that's when we have 0 rotations. Oops. We have 0 rotations there. Then if we go a quarter of the way, let's do 2 pi divided by 4, which is pi over 2. One quarter rotation is just going to give us pi over 2. Then half a turn, and we keep going. Then gives us pi. Half of 2 pi is pi. Then we keep going again. 3/4 of a turn. That's going to give us 3 pi over 2. And then a full rotation is 2 pi. So 0 and 2 pi both occur at the same spot. So 0 rotation and a full rotation occur at the same spot. This brings us to our next point, which is coterminal measures. What coterminal means is that it's two angles with the same terminal side. So right now we have this angle right here where this is the initial side and this is our terminal side. To find the coterminal measure, we would go a full rotation around this angle. So we go full rotation. Remember back in the last slide, our full rotation is 2 pi. So to find a coterminal measure, you just add or subtract a full rotation. Remember, full rotation is either 2 pi, which is in radians, or 360 degrees, which is obviously in degrees. So if your answer is in radians, you would add 2 pi or subtract 2 pi. And if your answer is in degrees, you would add or subtract 360. Next, we'll show you how to convert between radians and degrees. So we know that 2 pi and 360 degrees both represent a full rotation. So if we're trying to convert our degree measure into a radian measure, we can use this fact in a nice little ratio. So let's start off by saying we know that 2 pi and 360 represent a full rotation. And we're trying to convert 18 degrees into radians. So we're trying to figure how many radians is equal to 18 degrees. And we have two fractions equal to each other, so we can cross multiply, which brings us to 36 pi equals 360x, which means x is equal to 1/10 pi. Okay, now that's exact. You can put it in decimal form if you like, but I'm just going to leave it like that. So 18 degrees in terms of radians is 1/10 pi. Now we're going to go the opposite direction. We're going to change 5 pi over 6 to degrees. Same idea. We know that 2 pi is the same thing as a full rotation in degrees. And we're trying to find how many degrees are in 5 pi over 6. So now we're going to cross multiply. So we have 2 pi x equals 5 times 360 divided by 6 is about 300 pi. And now we just want to solve for x, so I'm going to divide both sides by 2 pi. That means x is going to equal 150 degrees. Alright, so we just converted degrees into radians and radians into degrees. Alright, before we go on, I want to make sure we have the coordinate plane down for radians and degrees. This is pretty much the staple for what we will be doing this whole chapter. So first I'm going to label the x and y axes with radians. So starting off right here, that's when we have 0 radians. When we go a quarter of a turn, that's when we have pi over 2 radians. Half a turn is pi radians. And then 3/2 of a turn, 3/4 of a turn is 3 pi over 2. Then it goes to 2 pi again. Then it could continue forever and ever, but I'm just going to stop at 0 and 2 pi. Now for the degrees. When we start, we're at 0 degrees. Then we hit 90 degrees. Then we hit 180 degrees. This all makes sense. Half a turn is 180. And then we hit 270 degrees. And then we hit 360 degrees. Alright. So, it's safe to say that in quadrant 1, we are either between 0 or pi over 2. Or we are between 0 and 90 degrees. Same deal for the quadrant 2. We're either between pi over 2 or pi. Or 90 degrees and 180 degrees. Quadrant 3, we are between pi and 3 pi over 2. And we're between 180 degrees and 270 degrees. And last but not least, in quadrant 4, we are between we are between 3 pi over 2. And 2 pi. And between 270 degrees and 360. Alright, after watching this video, you should be able to do a couple problems on, I believe this is page 434. And let's just try and do numbers 13 to 20 and 29 to 36. Okay, so we got 13 to 20, 29 to 36. They're just changing from degrees to radians or from radians to degrees.